So one question that comes up sometimes is, where does this distance equation come from when you're dealing with acceleration? Right, so to review, that equation is d equals 1/2 at squared. And a lot of people are like, why is it 1/2 and where is this t squared coming from? So I wanted to kind of break it down and show you through a word problem why that equation works, and really kind of showing you why it works. It'll start to make sense where it came from and why we're using it. So if the word problem was, you have a rate of acceleration of 10 meters per second, and you accelerate for 5 seconds, how far are you going to travel, right? What is your distance achieved during that time? So if you were just going to plug things in and use that equation, great, let's start with that. So d is what we're solving for, 1/2 of acceleration, which is 10 meters per second, times our time squared. So t is going to be 5s squared. So d is going to equal 1/2 of 10 meters per second will be 5 meters per second. And we're going to multiply that by 5 squared, which is 25, and s squared, which is s squared. Now what we can do is s squared cancels out, since there's 2 of them, we can cancel out with 2 s's. And we're just left with meters. Okay, so that's perfect since we're talking about distance. And 5 times 25 is 125. Distance equals 125 meters. So that's how you would solve that problem just using the equation. If you just wanted to plug things in and not even think about the equation, that's what you would do. Also, this gives us a good check so that when we're talking about why this equation makes sense and we're going to do it out by hand, we can actually check our answer right here. So what I've also done, so we're going to keep that kind of in the back of our head. So if we're thinking about this word problem and actually kind of breaking it down, I've made a data table. So here's our 5 seconds, right? You start at second 0, you travel to 1 second, 2, 3, 4, 5 seconds. In your first second, you're obviously, or at second 0, you're obviously at a stop. You haven't started this scenario yet. You start accelerating. You accelerate by jumps of 10, since we're talking about a jump of 10 per every second. So our jump goes up by 10, another 10, another 10, another 10, another 10. So since we traveled for 5 seconds at a rate of 10 meters per second squared, we know our final velocity is right here, 50 meters per second. Right? So hopefully we're all okay with that idea. Now the confusing thing is figuring out the distance. So this is where things get tricky. We know that in this 1 second here, right, this is our first second that occurs. In that first second, we speed up to 10 meters per second. So the initial idea would be, oh, if we speed up to 10 meters per second, we've gone 10 meters. Well, that's not entirely true. Were you going 10 meters per second the whole time? No. Halfway through that second, you weren't going 10. You were only going 10 meters per second at the very, very, very end of that interval, just when it turns 1 second. So at halfway through that first second, you're only going to be going half of this speed. So halfway through that first second, you're going to be going 5 meters per second. So if you spent the first half of that second getting up to 5 meters per second, and you then spend the second half of that second finally getting up to 10, what we're looking for in each of these increments is the median speed between 0 and 10, 5 meters per second. That tells you that on average, in that first second, you actually only were traveling 5 meters per second, because it took you half the time to speed up to 5, and then half of your time finally getting up till 10. So we know that in that first second, therefore, you travel 5 meters. Here, speeding up from 10 to 20, the median between those two numbers is 15 meters per second. So if you, on average, in that second traveled 15 meters per second, how far are you going to go? 15 meters. If here, the median being between 20 and 30 is 25 meters per second, which tells you that on average you traveled 25 meters per second, You, therefore, would go 25 meters. Here, the median is going to be 35, and here it'll be 45. And notice how, therefore, that tells us that we've gone 35 meters and 40 meters. If we add these up, 0 plus 5 plus 15 plus 25 plus 35 plus 45, what do we get? We get 125 meters. Now, that's a good thing. That 125 meters matches with what we came up from our equation. So, at the very least, it tells you the equation works, right? Because we can figure this out from a data table, or we can figure it out from the equation. This equation of d equals 1/2 at squared will work every single time. And if we're still confused a little bit about how we came up with 5 meters per second, remember that we're talking about what's the average speed that we traveled in this first second. Right? If we broke this problem down and we're only looking at this first interval, from when we started at 0 seconds to when we effectively stopped at 1 second, where we were eventually going 10 meters per second, how fast was our average speed there? So if we took 10 meters per second and we added it to our other speed in that interval that we know for sure, which is 0 meters per second, and we then divided them by 2, because those are 2 times. 10 plus 0 is 10, divided by 2 is 5 meters per second. So our average speed in that time interval was 5 meters per second. Another way of thinking about it is in the first tenth. Now this is going to get kind of confusing and have a lot of numbers and going to take a little bit of a stretch with the math here. But in the first tenth of a second, you speed up to 1 meter per second. In the last tenth, you're going 9 meters per second. So the average of 1 meter per second and 9 meters per second, 1 plus 9 is 10, divided by 2 is 5. In the second tenth of a second, you're going 2. In the second to last, you're going 8 meters per second. 2 plus 8 is 5. Or 2 plus 8 is 10, divided by 2 is 5. In the third tenth, you're going 3 meters per second. And in the third to last, you're going 7 meters per second. You add 3 plus 7 is 10, divided by 2, again, 5 meters per second. So you can also do that with 4 and 6, right? So what we come down to is, since 5 meters per second is the median between 0 and 10, it's also the average of 10 plus 0, we know that 5 is the average speed that you were traveling in that first interval. The same thing works when you're talking about 10 and 20. 15 is the median between 10 and 20. It is also the average of 20 plus 10 divided by 2. If we add up 30 plus 20, we get 50. 50 divided by 2 is 25. So that's why we're taking 1/2 of your acceleration, because we are talking about the fact that in this time interval, whether we're just talking about this first one, where it's 1 second, or the whole thing, where it's 5 seconds, you weren't actually going 50 meters per second until the very, very end. On average, you were only traveling 25 meters per second. So a much easier way of solving all this, rather than going each incremental second by each incremental second, is if we say, okay, the average of 50 meters per second over those 5 seconds, well, 50 plus 0, let's do this out, 50 plus 0 over 2, right, because those are 2 different speeds, is going to give us an average speed of 25 meters per second. If that's your average speed, and you traveled for 5 seconds, S times S cancels out. 5 times 25 is 125 meters. So just another way to verify that, once again, this is the correct equation and why this equation works. You don't actually speed up to that final velocity due to that acceleration until the very end. Most of the time, you are traveling, or on average, you are traveling at half of whatever your final velocity is, because you're speeding up to it in a linear fashion.